what a typical legacy or heritage system looks like at the moment. And it's not an accident that's got a carved stone background either. I couldn't find a cave wall, otherwise I would have done it in cave paintings. Very much integrated into one piece. Programmers on legacy heritage systems were always responsible for developing the physical database and for developing the logical database as required, writing the application code, and of course through display files, attaching an interface to the application code to communicate with the user. So it was very much a small picture, and it was managed by pretty much entirely by the programmers themselves. I'm going to make a statement here. I'll make it probably another 10 times or 20 times as we go through. But those of you who are thinking of getting involved in modernization need to appoint a database engineer. Because one of the most significant things about modernizing your existing application is you're going to take the database and separate it from your application logic. And you need somebody who is responsible for that database, because it will no longer be in the hands of your application developers. Let's have a look at where I'm going with that statement. This is the buzz phrase that goes along with modernization these days, MVC, Model View Controller. Except it's upside down. And it should actually be VCM. Because up at the top is the view. That is the interaction or the interface between the controller, which is your business logic, and the user that is utilizing the system for the benefit of the business. The controller is a section where the business logic resides. And your current legacy systems, and this is an important thing, your current legacy systems have that business logic built into them already. It's been evolved over years and years and years of expensive development by highly skilled people. And the last thing you want to do at a point in time is to take all of that and throw it away and do something else. What you need to do is you need to take that which you have and grow it into a modern, easily manageable set of logic. That's the controller. The model is your business model. This is your data. Sorry, I've done it again. Clicked the wrong button. The model is your database. It is that section of your enterprise that contains the information that makes the whole thing work. Change those around and just replace them with something else. Interface, processing logic, and database. Three things. What we do is we want to separate them. And this is where you begin to hear ripping sounds as you start tearing these pieces apart. Now, the interface, we know. That's been a component of modernization, and at one stage it was the only thing you needed to do to modernize, was to make your application look pretty. The interface is definitely a function and a part of modernization. Your processing logic is separated from the interface, and your database is then separated from your processing logic, i.e., your processing logic, that which defines and makes your business work, is in that middle layer. And what we do, the process of modernizing, is to start moving code that heritage or legacy-wise exists in the processing section of your application, because in fact your application only has a processing section. And we want to move code up so that some of the code goes into the interface modules, where the actual handling of the interaction between the user and the system is done. And then another large piece of code follows the route of being taken out of your processing logic and placed into the database where it actually belongs. Now, there's a classic example there, which I will give you now and we'll come back to later. If I want a user on an interface to type in a customer number or type in an order with a valid customer number, is what I meant to say, then the checking to see whether that customer number is valid at the moment is done by your processing logic. It should not be. It should be done by the database, because the database is ultimately responsible for the integrity and the validity of the data. And we will go into that particular statement later on. Okay, I've been stamped in the ribs again. When I suggested that it is becoming necessary when you modernize to identify a database engineer or database architect, I left out the fact that this doesn't necessarily have to be a separate person. It might be fairly intensive work to begin with, to start the modernization process. But once it's on its way, that becomes not necessarily a full-time job. And so it doesn't have to be a whole person. It could be a separate function of somebody who is already involved. Okay. Let's have a look at my block diagram of what a modern application should look like. This is what we are trying to achieve. And this particular course is going to cover all the pieces that I have here and how to achieve this. Obviously, it will have to be done in line with your existing application and your requirements of the system, naturally. But everything begins with the physical database. I'll probably come back to this a couple of times as well. The physical database is those physical files in the old DDS paradigm. So, yeah, DDS paradigm. I always get confused with this. And tables that they prefer to call them in the new DDL or SQL paradigm. Both of those form the physical database. And in the physical database is the data that keeps your business from failing. It's as simple as that. Without the database, your business, whatever it is dead. Because every decision that your business management and everybody else in the business makes is based on data that is stored in the physical database. It is the place which is most susceptible to espionage, to hacking. It's a weak spot if you let it be. And if people who shouldn't have get hold of that data, it can damage the business severely. I cannot stress enough that the data in your physical database needs to be protected at all costs. And here's a statistic that you probably don't know, is that accidental or deletion of data or other corruption of data or any other type of data mismanagement or damage is 80% of the time is not deliberate. It's accidental and it's done by people that work for you. And yet it can still put your business out of operation. So you're not even looking to protect yourself from those industrial espionage spies. You're looking to protect yourself against your own people. And that's not in any way a criticism of anybody. You need to, because that's where most of the problems on a physical database come from. Right. Let's see, what do we do when we're trying to create a modern situation? The first thing we do is we convert as much of our DDS database to DDL as is possible and practical. And the big and most important thing here is we want to do that without altering the level ID of the physical file at all. That is so important because you do not want to introduce other elements of other problems by being forced into a recompilation of your programs, which can run into the thousands. And if one doesn't compile, you're beginning to introduce errors. So what you need to do is you need to migrate your DDS to DDL without changing the level ID. That means you can simply switch to the DDL, what do they call it, paradigm, engine, whatever it is, the SQL or DDL engine, and you don't have to touch any of your existing code. It carries on running, and nobody even knows that this transition has happened. You can't convert all your DDS files to DDL because some won't convert. And some of them you may not even want to convert because they will be just too much trouble to bother with. I'm talking about that 15-year transaction history file that's sitting somewhere and is only used once every 18 months for looking up an ancient transaction because somebody's got a problem with it. Those files are not used. They're not really needed to be converted. The big advantage of moving to the DDL paradigm is the page sizes that you begin to deal with. A DDL file works in 64K page sizes, whereas a DDS file works in 8K page sizes. So almost immediately you should see an improvement in performance because the physical reads begin to reduce and the logical reads begin to increase. So there's a good reason for doing it, apart from the fact that DDL is the new thing. And in fact, IBM is putting a lot of effort into the DDL. And they are not developing the old index sequential access method type of DDS type of physical file too much anymore, although they have done some significant changes just on the last release. But they are putting most of their effort into the SQL engine, and as a result, it's not a silly idea to follow that and build your database as a DDL. Right. Having said that, that's where the beginning of your attention needs to focus. Now I'm going through these boxes a little bit quicker. Above your physical database, remember the physical database contains your data. The logical database is different ways of looking at that data. This is beginning the process of turning the data into information by giving you different sequences, different combinations, and different content. Logical database. But it is not part of your physical database. Then we have something, and this is what is significant from a modernization perspective, and the start of giving your database its own integrity, making your database self-aware, is the triggered programs, the database triggered programs, which you can attach to physical database files. And these triggered programs, which I'm going to go into in a lot of detail, provide the file itself with the ability to make decisions about the data that it will and will not accept. And these triggered programs are built from code that you take out of your business logic, i.e., you're reducing your business logic by taking away things like data validations. Must this field be a yes or no? Must this field be equal to naught or not equal to naught? All of those validations go into trigger programs and come out of your application code. And that means your physical database is becoming intelligent and it's becoming self-aware. Right. All of these I will be repeating ad infinitum as we carry on. Then we get a thing called I/O services. Translated is input-output services. My other name for it is border control, because it's actually the layer that controls the access of the application to the database, i.e., you are separating your application from your database, and you're providing a border control service which allows the application to access the database under supervision. What was it called? I heard it called recently. Delinking the database from the application is one of the main paradigms of modernization. And if you want to give your database autonomy, integrity, and flexibility, decoupling, there's another word for decoupling your database from your application, then your I/O services are the layer in which this is done. I will cover a number of other reasons why these I/O services are so critical, and I will show you how the I/O service layer goes a long way to help you protect your physical data in your physical database without making a huge effort at all. It's the border control, it's passport control, it's import-export control, and that is all done at that level. And the database, it protects the database from unauthorized access. Then we have another set of services, another service layer. And you will notice that the arrow on the right-hand side here, halfway through the enterprise services to the bottom of the trigger programs, is the model. That is the database. Enterprise services can be translated as being common services that are to be made available to the applications. The one that comes to mind and the one I use as an example is VAT calculation or tax calculation. I know that in the United States there are 3 levels of tax. In other countries they may be different, but the rules about how you calculate tax are very standard. And therefore, tax calculations are an enterprise service. They might use multiple logical and physical database files. You can see that from here. Here, this one and this one. Enterprise services can use logical and physical database files directly, as well as through I/O services, because these also have the same protection as your I/O services do. They will not allow uncontrolled access to the database. So that makes up your model. What's below this arrow here are more or less services that are focused on the database and usually on multiple database files, whereas the I/O services tend to be a one-for-one relationship with a physical database. The enterprise can combine more than one physical file or logical file into a service. The piece above, of course, is part of your application code, which forms the controller. So your application code makes use of enterprise services and I/O services, and therefore, as you can see, has no direct access to the physical database and or the logical database. And thus, you've managed to achieve a decoupling of the database from the application. Sorry, my mouse drawing is not great. So you've decoupled your application code from the database. What's below this line here, under the model, belongs in the database. The I/O server controls who can and who can't have access to this. The triggers determine whether the data is valid or not, and so on. So this is the big part of modernizing, is modernizing your database. I'm going to put in the user interface, which comes above that. Pointer options error. The user interface forms the view, which interacts with the application code and through the application code with the database, but has no direct access to the database. Now, there's one other thing that I add here, and I put this in reluctantly, because in fact, using embedded DML in your application code for quick access to your logical and your physical database is acceptable under certain circumstances. But I must stress that look at the way these arrows go. It's acceptable, if you do this, to extract data from either your logical or your physical database. But done properly, you will not be able to put data into your physical database directly from your application code. Whereas you'll see all the other arrows in this whole picture have a multi-directional, a two-directional function. This one is one direction only. Break that rule and you're exposing your database to all sorts of problems. Okay. So this is the stack that we're looking at for a modern application. And we will mostly be dealing with the database and application code changes, not to rewrite your applications, because only you can do that. But we will look at application code and the way of moving code from application to triggers and to consolidate application code into enterprise services so that you can reduce the amount of actual business logic in your application layer. And my experience and practical examples of this have shown me, and you will not believe me, nobody ever does, but you can reduce the number of lines of RPG code that you currently have in your application by up to 80%. Because 80% of the code that you currently have in your application programs is either user interface or database, and should be placed where it does the most good. Now,